Hello, welcome everyone who are watching this presentation. So this particular presentation is from the Center of Excellence in Land Administration and Management, Administrative Training Institute, Government of Karnataka, Mysuru. So on behalf of Center of Excellence, I am Dr. Vinay M, IT and GIS expert. So is currently working at the center. Right. So this particular center is mainly an initiative from the DILRMP, that is Digital India Land Record Modernization Program by Department of Land Resource, Ministry of Rural Development, Government of India. Right. So this particular presentation is about the NAKSHA pilot program that is launched by the Ministry of Rural Development, especially concentrating on the urban areas. So the abbreviation of the NAKSHA, so National Geospatial Knowledge Based Land Survey of Urban Habitations. So before going to the NAKSHA, we will see what is the DILRMP program, what is the significance of the DILRMP by the Ministry of Rural Development. So DILRMP is mainly related to the digitalization of the land records with accuracy and updated status and access to the public in easy and online mode. That is where that becomes very important in nowadays, because we are heading to the digital world. Digital economy is increasing day by day, so we have to modernize the land records from the legacy land record system where we had a paper based land records earlier. Nowadays we are going to modernize it through the IT and ES facilities. So DILRMP is a Government of India initiative launched in the year 2016 to modernize the management of land records, minimize the scope of land property disputes that is happening at the ground level, and to enhance the transparency in the land record maintenance system. So this DILRMP actually it is started in the year 2008, but the old name is the National Land Record Modernization Program, that is NILRMP. So in the year 2016, the government of India has renamed the NILRMP into DILRMP, and new components were added, such as the computerization of revenue codes in the country. So if any disputes are there, how to address the disputes. So these are all the things that brought under the DILRMP scheme, where computerization of revenue codes in the country. And also another component is the integration of land records with RORs, record of rights, along with the Aadhaar number integration. We also call that as the Aadhaar seeding. So these Aadhaar seeding can be done with the consent of the landlords. Right. See, these are all the two new components that brought under the DILRMP. So before that, these two components were not there in the NILRMP scheme, which was approved in the year 2008. Right. So we have seen a major boost in this program by the DoLR, and active involvement and active engagement of the DoLR is evident, and all the states are following the uh, DLRMP program, and majority of the states are modernizing the legacy land records, and in near future we can expect the modern and up to date digital land records of the India at the very parcel levels. So this are also, and one more thing is every state has its own land laws, and every state has its own way of managing the land records. In order to standardize the land records across all the states, this program is very important in a diverse country like India. So, under the DLRMP, these are all the major components that we can see. That is computerization of land records, especially the RORs, record of rights, uh, then digitization of cadastral maps, integration of RORs and cadastral maps, and establishment of the data centers at the state level. So these are all the components which is under the DILRMP. And the second component under the DILRMP is the computerization of registration. So earlier, without the support of IT, manual and the traditional way of registration were followed up in the different states, where it took more than a month, more than a quarter to uh, process the registration of lands. But in order to reduce the time taken during the time of registration, so the registration process has to be streamlined along with the computerization of record of rights. This is also one of the components in the DILRMP scheme. And another thing is the conduction of the survey and resurvey. If a survey already done, then there is a requirement of resurvey to ensure that whatever we are representing in digital form, that are all up to date. And if a particular state is not at all done a survey, then the survey activities need to be undertaken through the survey and settlement SSLR department, survey settlement and land records department of the different states. Then another component is the establishment of modern record rooms, where the digital land records are kept in digital forms. Either it can be in the form of the servers, or it can be in the form of cloud servers, right? So these are, and the easy way of access to the land records that made under the DLRMP scheme. And one more thing is the training and capacity building. So the training and capacity building is the main thing that DLRMP is boosting up. And our center, that is Center of Excellence in Land Administration and Management, is one of the ATIs in southern part of the India, which acting as a nodal agencies to cover different states like Karnataka, Kerala, Tamil Nadu, Andhra Pradesh, Telangana, and three union territories like Pondicherry, Andaman and Nicobar, and Lakshadweep Islands. So establishment of project management unit under the different states, that are also part of DLRMP component. Then computerization of revenue court management system, RCCMS. Then these activities need to be integrated in this particular scheme. Then another component is the integration of Aadhaar numbers with the land record database on voluntary basis. So the Aadhaar seeding. So earlier there is no documentations are linked just with the name we had information. Now with the help of Aadhaar number we can perform the eKYC and we can validate the authenticity of the ROR, and in order to maintain the transparency in the registration process and to make sure that the proper landlords having the records. So these type of authentication is must for the current technological world, right? And as discussed that the establishment of the ATIs at the different states, right? So the DOLR has selected 5 different institutes across India to act as a DLRMP monitoring cell. So among that, our administrative training institute at the Mysore covers the southern part of the India, and Yashwantrao Chavan Academy of Development Administration (YASHADA), which is mainly used to cover western part of the India. Then Labasna Lal Bahadur Shastri National Academy of Administration at the Mussoorie to concentrate these states like Bihar, Jharkhand, Odisha, Uttar Pradesh, Uttarakhand, and West Bengal, and Mahatma Gandhi State Institute of Public Administration at the Chandigarh to concentrate on the northern part of the India, including the Union Territories of Jammu and Kashmir, Leh Ladakh. So it's, and another institution is the Assam Survey and Settlement Training Center AISSTC, which is mainly used to concentrate on eastern part of the country. So these are all the coverage of different center of excellence, and it's the allotted states to monitor the activities of DLRMP. And coming to the point that the NAKSHA, so the DLRMP having a different programs, and one of the recent program that is launched that is called the NAKSHA. This NAKSHA project mainly to concentrate on the urban areas rather than the rural areas. For the rural areas, we have projects like Swamitva and the resurvey, right? So if Swamitva concentrates on the rural habitats, then resurvey will concentrate on the agricultural plots outside the village limits. Then what about the city limits? Within the city limits also we do have a land parcels, the survey numbers, everything. So that also need to be maintained and managed within the DLRMP scope. So for that the DLRMP has launched the pilot program. So this is the pilot program where nearly 100 plus cities are selected across the India. If we take the statistics regarding the allotment of the cities, nearly every state's got the 10 ULBs, urban local bodies, to implement the NAKSHA pilot program. So as the abbreviation says, the National Geospatial Knowledge Based Land Survey of Urban Habitation. So the geospatial, so we have to understand the word geospatial. So geospatial, spatial is nothing but the space. We are studying about the geography. So geospatial is a compound word. It's nothing but mainly we concentrating on the location aspects of the land. So that's what it's geospatial is the geospatial science and technology is a modern tool to manage the earth system. So especially in the land management, so we frequently adopt the geospatial technologies, differently geospatial technologies like drone technology, like remote sensing, satellite based, aircraft based, imaging, aerial imaging, taking the images of the satellites. Uh, uh, Through the satellites, we are taking the images, and those images will give us the meaningful information regarding the Earth's surface, right? So if we have a imagery of a particular area, then it is easy for us to understand the current status of the particular land, and if we have a multiple time period data, then through the time how the particular land got changed from one time period to another time period. So these are all, we call that as a temporal analysis through the time how a particular land changes its morphology. So these are all the things that we can study through the NAKSHA. So that's what the DoLR has initiated, the NAKSHA across 150 cities to study how the modern geospatial science and technologies can leverage the land survey activities, and based on the learnings, then it is expected to implement across all the cities in within the India. Right now, since it is a pilot program, only 150 cities are nearly 100 plus, that is especially 150 cities are selected. Okay, so the main aim of this NAKSHA project is to create a accurate and up-to-date urban land records. This is not about the rural land records, especially it's about urban land records. So the objectives, so to precisely say, it is that 150 two urban local bodies are selected across all the 29 states and union territories under the NAKSHA. So the objectives are to enhance the urban land records and to improve the urban planning process, especially the urban planning where the existing land use, proposed land use, and how to limit the future development towards an unsustainable areas, and whether we are attaining a sustainable growth or unsustainable growth. These are all the studies we can able to study through improvising the urban planning. If a particular city is accelerating the informal settlements, then how we can control the informal settlements. So these are all under the NAKSHA, and to empower the urban citizens. So some of the properties are under the disputes, and some of the properties may under the litigation, and some of the properties may not have a proper documents. So in order to provide a legal documentation to the lands within the urban area, so this NAKSHA project going to helpful for those. Then strengthening the property tax assessment. So if we have a precisely marked the precisely marked roads, buildings, residential layouts, whatever. So based on the built area, we can easily assess that how much tax that we need to collect, and precise estimate of the tax can be done, and the collection part will become very easier when we map all the buildings, all the assets within the urban area. So this is about the objectives of the NAKSHA. So who are all the stakeholders who are all involved from grassroots level to the final execution phase, right? So the first primary mother department is the Department of Land Resource under the Ministry of Rural Development, who funds this NAKSHA project and acting as the facilitators. And along with the Survey of India, the DOLR has tied up with the Survey of India as a technical partner to establish the SOPs, standard operating procedures, to execute the NAKSHA project across the different states. Then The implementation partners are nothing but the state government. So every state government procures the NAKSHA project and the funds from the DoLR, and the state government responsibility is to constitute the committee and to execute the NAKSHA project. Then third party vendors are the part of the NAKSHA project, where if particular state not having a facility to conduct in-house survey, then obviously they have to outsource the aerial surveying task. So the third party vendors like corporate companies and NGOs, so those who involves in surveying activities, they can become part of this NAKSHA project. So they have to participate through bidding, and successful bidders will become vendors for the aerial survey and mapping. So especially when talking about the Karnataka government and SSLR, survey settlement and land records uh, will become the implementation partner for the NAKSHA project. So if we talk about the program management structure, we have three levels of program management. One is the national level, state level, and urban level, as discussed in the previous slide. That national level DoLR, Department of Land Resource and Survey of India. At the state level, SPMUs, the government, state government has to initiate this. Then at the urban level, coordination with the ULBs, the Jilla Panchayat, so who are at the corporation, urban development authorities are under the urban level. So it is up to the state committee to decide whom to involve and whom not to involve to execute this NAKSHA project. And if we talk about the role of Survey of India, the role of Survey of India is to procure the aerial survey vendors. So aerial surveying is the use of equipments like drones. The drone will fly aerially in the airspace. While flying, it captures the image. Those image will act as a digital digital product for us to demarcate the land area. So the main role of the SOI is to identify the potential vendors for aerial survey and procurement of the equipments, are also the role of the Survey of India, and supervision of GIS data processing. Like since it is across the nation, the technical capacity and the knowledge of the implementer from one state to another state will differ. And in order to standardize the NAKSHA project, so we require a standardized methodology, standardized framework to process the geospatial activities and geospatial data that is coming out from the survey. So the main role of the SOI is to monitor the data coming out from all the states, all the ULBs, and to perform a quality checks, quality assurance. These are all the tasks of the Survey of India. And another point is the establishment of CORS and GCP network. So GCP is a ground control point. It is nothing but establishment of high accurate latitude and longitude of a particular point or particular location, that is the GCP. And the course, the continuously operating reference station. So the course is a kind of the GPS instrument. So GPS is one of the technology in positioning, but generally we do not call it as a GPS. Instead we call that as a GNSS. global navigation satellite system. So this global navigation satellite system is one of the technology under the geospatial science and technology, where this GNSS is a constellation of satellites which continuously broadcasts the radio signals, and those radio signals are received at the receiver, and receiver determines the position of the users at the ground level. So if we have an instrument like let us take the example of mobile. If we turn on the GPS, then through the Google Maps we can able to identify where we are standing. So how it is done through means it is done through the satellites, the GNSS satellites that continuously broadcast the radio signal. The radio signals are received at the mobile, and the receiver will determine the position of the users through the mathematical way, that is by identifying the latitudes and longitudes, and also the altitude of a particular person standing in a particular location, right. So this is the thing. This GPS, that is GNSS, is not only used in the land surveying, but it is used in various applications, like it from the military, agriculture, transportation. So we have a wide range of applications with respect to the GNSS systems. So, and since we day to day basis we use a GPS in our mobile, that will become a handheld GPS. These handheld GPS may have mm, accuracy issues, where 3 to 4 feet, 3 to 4 meters errors will be there. So whatever the latitude and longitude we are getting, that is not almost accurate. So it may have some errors, plus or minus the tolerance we need to audit while doing the survey. For general applications like regular commuting, these are all not at all issues. Why? Because regular mobile GPS is enough to travel from one location to another location, even though if there is a displacement in the latitude and longitude at the ground level. But in the case of land surveying application, we require almost centimeter grade accuracy, where less than 5 centimeter accuracy we require to attain and to precisely demarcate the land parcels. So to precisely demarcate the land parcels, then it is not possible to survey with the normal mobiles or a normal handheld GPS devices. So in such case, we have to go to the higher version equipments, that is we call that as a DGPS, Differential Global Positioning System. So this differential global positioning system is a highly accurate instrument, where it not only depends on a single system like our mobile. Our mobile is mainly depends on the GPS, which is designed by the USA. But the differential GPS not only depends on the one system like a GPS, but instead it will depend on the multiple country and multiple country satellite systems, like the differential global positioning system is kind of instrument which receives the signals from the USA based GPS, and GLONASS from the Russia. So from the Russian constellation of satellite also we are receiving the signals. Then from the Galileo European based satellite constellation, from that also we are going to receive the signals. And Baidu, the Chinese based satellite constellation, from that also the DGPS is going to receive. So that means our mobile is depending on one particular system, but the advanced instruments like a differential global positioning system, which receives the signals from the multiple constellations of the satellite. So when we receive the multiple phase of signals from the multiple system, then we can easily attain the accuracy at the ground level, where centimeter accuracy can be attained. So we call that as a survey grade equipment. So our mobile is not a survey grade equipment, but the differential global positioning systems are the survey grade equipments, where centimeter level accuracy can be attained. In the with the place of mobile, our mobile is a 3 to 4 meter accuracy. So 3 to 4 meter difference is there, means we cannot able to demarcate the land parcels at the ground level. So that's what the precision matters while conducting the land survey and land survey activities. So based on this, so if we have a instrument, okay, I'll show you in the next slide. See, we have two types of working mode. As I said that this is the instrument called the differential global positioning system. So if we have this instrument, we will get two setups. One setup is a base station and another setup is a rover. So this base station we have to so let us say if I am conducting a survey at the city X, let's say I am conducting a survey at the city Mysore. So when I start the survey, when a surveyor starts the survey, they have to establish this base station, and this base station will continuously collect the signals from the different satellite system. So once all the signals are collected, the accurate location of this base station is determined by the base station. But what happens with the rover? So the rover do not collect all the signals, but instead it will depend on a one particular system like a GPS. Then the base station have a accurate information about the latitudes and longitude of the base station, and also it has a link between the base station and the rover through the ultra high frequency. We also call that as a UHF radio transmission, right? Then through the rover, so this is fixed at one particular location. Let's say I have established this base station at some high elevated areas like railway station or any other high rise buildings I established, and I will move this rover from one place to another place. As soon as I move the rover from one place to another place, through the connection between the base station and the rover, the difference between the base station and the rover, the difference in distance between the base station and the rover is calculated, and the differential corrections is applied. So the rover may receive the latitude and the longitude, that is the signals, and the rover processes the signal, and the rover determines the latitude and longitude, but the accuracy of the rover is always less compared to base station. So in order to correct the inaccuracies that is generated by the rover, the base station is established. So the base station will try to correct the errors that is generated by the rover. Then if a person moves the rover to another place, again in that place also the errors will come. The errors will be corrected through the base station. So like this we can able to attain the collection of the points. The points we call that as a GCP ground control points. So this is the working mode 1, and we have working mode 2. So I will tell you what is the main difference between this working mode 1 and working mode 2. Let's say in a day 1 I have established the base station and I completed one part of the Mysore. Then I have to in a day 2 again I have to set up this. So if you want to set up the base station, at least it will take 1 hour or 2 hour, depends on the number of signals that is receiving at this particular base station. So every day we have to install, and every day we have to wait 2 hours in order to install the base station, and the base station will continuously receive the signal. So once minimum satellites are acquired by the base station, then we have to start. So that means, so every day we are wasting the 2 hours for installing the base station, and after that only we have to start doing the survey. So in order to bridge this gap where 2 hours of time we are wasting at the working mode 1, the working mode 2 will compensate this gap by utilizing the cores. So the course is nothing but like the base station. So we have a single base station, right? So like this base station, we have nearly 100 plus base stations installed across the India through the Survey of India. The Survey of India has established base stations like this. So you do not want to establish every day. So you, in a day one, okay, you switch on the rover and connect the course. So course means at a certain distance, the Survey of India may have a DGPS like this base station. So the base station continuously receiving 24 into 7 into 365 days, right? So this particular device, like a device, will have an internet connection. Then through the network, so we can able to connect it to this rover by mentioning the IP, by mentioning the username and the password. Once you connect to the base station which is established by Survey of India, then instantly you can start conducting the survey. You don't need to wait for the fix. So fix is nothing but you do not want to wait for the base station in a working, like in a working mode 1. So working mode 2 is a instant process. As soon as you go to the field, you can start collecting the latitude and longitude of a particular point, so without wasting the time. But in the working mode 1, you will waste the time by fixing your own base station and you need to wait for the fix. So this is the time concept. So that's the course. Course is nothing but the continuously operating reference system. So if you look here, these are all the points where the Survey of India established the base stations. It is continuously operating 24 into 7 into 365 days. So if a surveyor is at this particular location and he can able to choose any one of the base station to connect to the rover and start conducting the survey. Right. So the course by Survey of India. So to liberate users from setting of their own reference station each time they wish to undertake GNSS measurement, Survey of India has established a network of continuously operating reference station, which is called as a course, which is not only capable of providing the real-time positioning system through RTK. RTK means real-time kinematics. NRTK means networked real-time kinematics through the RTK will work through the radio signals directly in contact with the base station and the rover, but in NRTK is the networked real-time kinematics, where through the cell phone towers and through the internet connection we can able to send the signals and we can able to correct the errors which is attained by the rovers. See, if you look at the course will give the accuracy of plus or minus 3 centimeter of accuracy. And one more thing is, if you are close to the course, more accuracy will come, and if you go away from the course, then a gradual inaccuracies can be seen. So it's a distance matter between the base station and the rover. And if you have just a rover, as per the working mode 2, in the working mode 1 you should have a base station and you should have a course. So if you want to purchase that setup, nearly it will cost around 12 lakh. This setup will cost you around 12 lakh. So the famous companies are the Leica and the Trimble. So these are all the top two dominant player in the market of the GPS, especially the DGPS. And if you want to go with the working mode 2, then you do not need to invest 12 lakh rupees. Just a rover you need to purchase. This rover may cost you around 3 lakh, 3 to 4 lakh. Just a rover is enough. And one more thing is, you have to subscribe to the course network through the Survey of India. The course service is not free of charge, so you have to subscribe by paying the prescribed money. So it's depend on whether you are subscribing daily wise, weekly wise, monthly wise. Suppose your task may be limited to one day. If you are planning to survey only one village, means you can go with the daily. subscription day wise. For that particular amount is mentioned by the Survey of India. And if you are executing a large project, means you can go with a monthly or yearly basis by paying some subscription charge to the Survey of India. So you can visit this particular link to get the more details regarding the course. So once you subscribed the course service from the Survey of India, they will provide you the IP address, they will provide you the username, and they will provide you the password. You just need to configure those IP username and password in the rover, then start surveying without delaying in the ground. So this is about the course. So what is the role of state and union territory governments? So the role of the state and union territory governments is to provide the existing land records, legacy land records, and assist in the field surveys. Then manage the dispute resolution and public engagement. Then methodological overview, as we discussed, that it uses GPS, the differential global positioning system. So once the GPS points are collected, then another component of the NAKSHA project is to conduct the aerial survey through the drones in order to get the physical features of the particular area, like building, roads, whatever the utilities, amenities are there in that particular area, that can be easily extracted through the aerial images. So once we have a satellite imagery, then we can go with the feature extraction, where 2D features like aerial information, uh, like building footprints, the tree points, coral points, road width, everything that can be extracted. Then 3D information can be extracted, where in the 3D we are going to extract the height information regarding the building, trees, water tanks. So whatever the infrastructures available within the urban areas, that we can able to extract through 3D extraction. So in the upcoming slide, I am going to show you how these can be done. Then field surveys need to be done. Then ground truthing. So ground truthing is nothing but to check the accuracies after conducting the survey. If the surveyor conducted a survey, then simply we cannot able to accept the data. So we have to go to the field and we have to ground truth it. So ground truth verification, we also call that as a GTV task, that we need to take care of. So once the data is accepted through the ground truth verification, then it is our task to do the data processing and integration. So all the buildings, all the land parcels, all the utilities are extracted, then it is time to integrate all these data into the record of rights, so, and issue the property cards to the landlords. This is the methodological overview of the NAKSHA. So this is the example of the 2D extraction from the aerial view, that is the top view. The building, the dimensions are extracted through the polygons. So these polygons will help us to maintain the digital records of the building. Each polygons will be assigned with the ID, like RPOR or the UPOR, urban property records, or the rural property records. Then each building details, like who is residing and how many floors, how many, what is the type of the floor, what is the type of the roof, and the neighbors information, and who is the family head, the ration card information. So major, see, once we demarcate the polygons like this, we can integrate a lot of attributes. There is no limitation. So thousands of attributes we can integrate for a particular location. As I said that through the drone we have to conduct 2D mapping and a 3D mapping. So in the 2D mapping, what happens, the drone will be flown at a certain altitude. So according to the drone policy, the maximum height the drone should fly for normal aerial survey activities is the 400 feet. So less than 400 feet only we have to fly, and the camera mounted to the drone will exactly look at the ground. So that we call that as a nadir cameras. So nadir means the drone camera is exactly looking towards the ground, that is nadir. So in that case only we can able to see the aerial view of the particular area like this. So the aerial property, we cannot able to see the side view of this building. So suppose if you want to see the side view of the building like a wall, and if you want to study the height of the building, in such case what you need to do is you have to fly the drone in the oblique mode. Oblique mode means the camera should be tilted at a certain angle, so the side information of the building can be demarcated. So there are two types of imaging. One is called nadir imaging, and oblique are also called as a off nadir imaging. So in the off nadir imaging, the camera will be side looking. And in the recent development, we have a single camera which is having a 5 sensors in that, where in a single fly it will capture 5 different images at the 5 different angles. One is nadir and off nadir images that can be done. So we call that as a oblique camera which contains 5 angles. And we have different sensors like LiDAR, light detection and ranging, which collects the point cloud of a particular area. So in the next presentations, we will discuss in detail about how the drone imaging works, how LiDAR works. So keep watching our playlist for better learning. So right now I am generally will talk about the LiDAR. So light detection and ranging, which acquires the information about the ground through the point clouds, mainly depending on the light energy. So this LiDAR is mainly used for 3D mapping of a particular land area. So as I said that, see here now it can be a drone, it can be a aircraft. If the sensor is exactly looking towards the ground, then we can see here the red thick line is these information only can be mapped. If the camera is side looking, the side information like a wall facets, everything can be mapped. So through the concept called close range photogrammetry or aerial photogrammetry, so we can able to measure the height of the building if we have a oblique data. So that means side information of the building. If we have a image, say like this, here we have a building, we can able to see the side information of the wall. So based on the close range photogrammetry, it is easy for us to measure the height of the building. But in the case of this, we cannot able to measure. Why? Because this particular image is flown through the nadir based drone. So here in this case we cannot able to attain the we cannot able to measure the height of the building. But in this case the height of the building can be easily measured. Why? Because the side angle of the building is clearly visible. This type of images are captured through the oblique camera. So this is the example of the LiDAR, light detection and ranging, where it collects the points through a multi-beam. So we will discuss in detail in the upcoming videos regarding the LiDAR, how LiDAR works, everything. Then ground control points. So the ground control points are nothing but the markings at the ground, and the lat long of this particular point is acquired precisely through the GPS, that is differential GPS. In the feature extraction, the 2D, 3D GIS data creation as done. See here, if you look here, the total the parcels as digitized, and within that the building informations are digitized. If any water flow or water body is flowing, any stream is flowing, that informations are digitized, and even the road informations are so property boundary, building, utilities, road, drainages, all the visible features from the image can be digitized through a technique called GIS, Geographical Information System. Mainly we use a software, if it is commercial, we use a software called ArcGIS, which is developed by the company called ESRI, Environmental System Research Institute. And if it is open source free version means we use a software called QGIS, Quantum GIS. Those softwares can be used by utilizing these base maps. So we call this as a base map, and by drawing and by tracing the features, then we can easily extract the point line and polygon from the images. So once we have data from the drone, then our task is to generate the orthorectified imagery. So orthorectified imagery is corrected with the distortions like radiometric distortion and geometric distortion. So what is that radiometric distortion means? If you look at this raw imagery, the color is little bit blurry. So once you attain the orthorectification, the color enhancement will be done, and there will be a certain displacement in the image, and the terrain information is not visible in this raw data. So if you fuse the raw data with the elevation model, then we can able to attain the orthorectification process, and in the orthorectification highly precise and accurate base map can be generated. So through the drone data we can able to get the DEM, that is digital elevation model, the altitude information about the ground. Suppose let's say if a particular city, so above the mean sea level what is the height, so these can be extracted through the GPS information. So the GPS not only gives the latitude and longitude, but it also gives the altitude, the height information above the mean sea level, that also it will give. So digital elevation model and digital surface model. So in the surface model, your building information, building dimension, tree dimension, all the things we can able to get through the DSM. And the DTM, digital terrain model, the bare earth surface. So these things we can able to. So these are all the products from the drone processing. So in upcoming lecture series, you will get to know how to process the drone images. Those are all the things we are going to teach. So you have to keep on watching our playlists. Then once we have the data, once we have extracted all the information, then we will integrate those information with the record of rights and issue the property card. So this is the sample of the DSM, digital surface model, where here you can able to see the height of the buildings as well, but in the DTM only bare earth elevation we can able to see. So these are all the digitized records. Then once the digitization and integration everything is done, then we have to go with the quality control measures, where it contains different stages, where post flying data review. Once the drone is flown, then we have to review the data, and we have to perform the ground truthing. Once ground truthing and once extraction everything is done, then we have to go with the dispute resolution and correction. So we have to consult with the Grama Sabhas, and we have to consult with the Panchayat officers. We have to consult with the village accountants regarding the accuracy of the integrated data. So once the accuracy and once the attribute and once the attribute accuracy and the spatial accuracy of the data is verified, then it is our task to issue the property records. So regarding the financial sanctions, the DoLR, Department of Land Records, currently released nearly 193.81 crores of total budget, and the major components are to conduct the aerial survey and the GIS. Nearly 76 crores are allotted for this, and in order to purchase the equipment, nearly 62 crores are allotted to purchase the rovers and to subscribe to the course stations, and to develop the MIS, that is Management Information System, and also we call that as a WebGIS. WebGIS is nothing but where the point line and polygon digitized that can be displayed through the web, like a Google Maps. Google Map is also one of the example of the WebGIS. Like this, we have a property, polygons, road lines, all the feature points. These point line and polygon are integrated within one website, and the interactive in an interactive nature. And if we click on that particular polygon, then whatever the attribute informations are integrated, that we can able to see if we have authorization to the particular website. Then through the NAKSHA, the training and capacity building are also part of the program. A different time period trainings are frequently conducted: 1 day training program, 3 day, 5 day, 7 day, 10 day. So it's up to the requirement by the state government and at what level the manpower has given the training. Yeah, at the grassroots. So majoritarily the ADLRs, Assistant Director of Land Records, and the surveyors need to execute at the ground level. So if there is any gap in the knowledge, then we have to bridge the gap through conducting the frequent training programs. As a part of a Center of Excellence in Land Administration and Management at the ATI Mysuru, we are also into the capacity building. Then IEC activities for the public awareness. These are all the things. So the training programs, through the rovers, DGPS, drones, survey program. So these are all the flyers by the DoLR. So DoLR having a handles in the Twitter, Instagram, LinkedIn, Facebook. So you can follow. Even we also having the handles. Then you can follow us for the activities that are done at the ATI Mysuru. So especially in Karnataka, the resurvey project has successfully completed in Doddahalli at the Kanakapura district, where Karnataka Doddahalli becomes the first village in the state to complete the land resurvey using a drone and rover technology. These technologies and the success stories as evident, and the Karnataka government are constantly boosting the resurvey schemes and continuously working in the different districts, and within the next 2 to 3 years of time span it is expected to complete. So the Center of Excellence in Land Administration and Management are in coordination with the different states, as I said, that Karnataka, Kerala, Tamil Nadu, Andhra Pradesh, Telangana, and other 3 union territories. So we collaboratively working towards bringing out the success from the NAKSHA project, the LRMP scheme, and that going to happen within stipulated time. Then what is the expected outcome of the NAKSHA project? So once the NAKSHA project is successful, then the improved transparency in urban land records that can be done, then better property taxation and revenue generation can be attained, and support for smart city planning, that is master planning purpose, like Amrut DTCP master plans, whatever. Then standardized property assessment. So across all the states, all the cities, a standardized property assessment framework can be brought down. Then reduction in revenue losses, and fairer tax collection process can be attained. So this makes the end of this presentation, and thank you. So if you have any questions, if you have any queries, please write us so in the comment section, and keep watching our playlists. Thank you everyone, and have a nice day.